There is a lot going on in this diagram. The point of it is that the stream character changes from the headwaters down to the mouth of the stream. At the headwaters, up here at the top of the watershed, the gradient of the stream can be quite steep. So going to this cross section here, this is source up here on the left and the mouth down to the right. At 1, which is in the headwaters, maybe one of these small tributaries, the gradient or the slope of the stream is quite steep, the drop in elevation per distance flowed. That would be like Boone. In Boone, we have really steep streams. Going down to number 2, between 1 and 2, there is this cross section A to A prime, and that coincides with this cross section here on the left. It shows a very steep-sided floodplain with kind of a notch cut out here, with the stream channel being this really pointy V. Getting down to B, so we've gone from 1 to 2 to 3 to B. B is showing that the floodplain widens, the stream channel is not so V-shaped, it's more rounded. And then getting down towards the mouth of the stream at C, down towards the delta, the floodplain really flattens out. It's a really pronounced floodplain. We can find the edges of the floodplain. And the stream channel has also incised down into the floodplain. So it has a really defined shape to it. At the mouth of the stream, the gradient is very, very low, and that leads to base level. Base level is basically where the stream empties out into, and it's usually going to be sea level or elevation equals 0, and it can be a lake. So lakes also can be base level, but for most streams, the end is the ocean. Just to summarize that, then, near the headwaters, the gradient is steep, the discharge is relatively low, the watershed at this point is relatively small. As you go downstream, the watershed gets bigger and bigger and bigger and bigger, and the discharge is going to increase because there's more surface area where precipitation is falling, so it gets bigger. The competency is going to be high in the headwaters because the velocity is going to be high, so there more sediment of bigger sizes can be moved. Also, in the headwaters, the channels are usually going to be pretty straight as they come straight off of a mountain. Further downstream, near base level, then the stream here is meandering. The gradient is nearly flat. There's really not a perceivable slope change in this image. The discharge is going to be relatively high because at this point the watershed is huge in the downstream location. The competency is going to be fairly low because that gradient isn't very high. The velocity isn't going to be very high. So the class size is going to be relatively small. And the stream is going to curve and twist and do these meanders. So it really shows a difference between headwaters and down towards the mouth. All right, that term base level has a definition. It's the lowest point to which a stream can erode. It's usually going to be the ocean, but it also can be a lake. So here it's labeled as the local base level. Sea level is the ultimate base level, but sea level can change, right? Sea level rise and fall. There's also tectonic changes, subsidence, where the land surface is sinking. All of that can change. So base level can change over time. This image here is kind of a cartoon of the goosenecks of the San Juan, and the stream channel was meandering through these flatline sediments, and then the mountain, the Colorado Plateau, uplifted as the river just dissected down into that meandering channel.